If you could please put your hands together for the virtually present Bob Bray. Give him a round of applause.
Hello, everyone. It's great to be presenting at the Construction Innovation Forum today. Unfortunately, my schedule did not allow me to be there in person this year, but it's great to see people gathering in person again. When we first started exploring the topic of digital twins at Autodesk, we quickly learned two things. First, if you ask 10 people what a digital twin is, you were likely going to get at least 10 different answers. Second, the process of creating a digital twin is pretty challenging. Today, every digital twin created requires a fairly costly bespoke process of data collection, validation, and system integration. In looking at those solutions, we realized that all the data required to create the foundation of a digital twin is data that is created or captured during design and construction. Autodesk Tandem was born out of this realization that if we could harness the data from design and construction, then we could create a highly repeatable process for realizing digital twins. Because I'll be sharing future development plans with you today, and those plans may change over time, purchasing decisions should not be made based on this presentation. That's what all that text says. You don't need to read it all, trust me. For an agenda today, we'll talk a little bit about digital twin, kind of the opportunities and challenges they present, along with a definition from Autodesk's perspective. We'll talk about the idea of digital handover. How do we start projects digital, keep them digital, and deliver them digital? Talk about how we then move forward into connected buildings, transforming all of that data into actionable insight. And we'll close with a demo, some roadmap, and how you can get started today with Autodesk Tandem. As we get into it and think about a digital twin, we'll start with our definition. A digital twin is really just a digital replica of a built asset. But what's important is that it's a dynamic digital reflection of that physical self. It needs to possess a bidirectional connection to the physical asset in order to possess the operational behavioral awareness necessary to simulate, predict, and inform decisions based on real-world conditions. At Autodesk, we think there's a bigger opportunity though, and that's really thinking about how we transform the built asset lifecycle. We can affect that transformation together by really tracking what we like to call a digital thread of information that links organizations and data with an end-to-end digital process spanning capital planning, architecture, engineering, construction, and asset management. Transformation starts by understanding the owner's desired outcomes. Everything starts by understanding what you want to accomplish. That includes their data requirements and beginning to track that digital thread through the planning, design, and construction lifecycle to create that digital replica of the as-built. And then extending that digital thread into operations, we can create a single pane of glass for correlating operational data and use that rich data for predictive insight. Finally, the knowledge collected by the twin can inform the capital planning portion of the lifecycle, giving owners additional insight, such as, are my facilities achieving my sustainability goals? And if not, what can I do to course correct? Or what could I do to design better in the future? Which systems, equipment, and materials perform better than others across my portfolio? And what future planning and design decisions will maximize my ROI and ensure I hit the goals that I've set for my portfolio? Shortly after we got started on Autodesk Tandem, Verdantix proposed a maturity model for digital twins comprised of 5 levels. The base level they call a descriptive twin, which is really that idea of a digital replica of the as-built facility created from design and construction data. That does not need to be a bunch of LOD 500 level Revit models with every nut and bolt in the curtain wall. It needs to contain those assets, the spaces, and the systems that need to be monitored and maintained for the life of the facility. Informative twins add to that by connecting to operational and sensor data to create that single pane of glass, the ability to correlate and visualize all of that data contextually. Predictive twins then begin to leverage that operational data for predictive insights. When might this component fail based on past history? Comprehensive twins add simulation for future what-if scenarios, and autonomous twins take it one step further by having the ability to learn and act on behalf of users and or self-tune a facility. Each level requires a greater degree of maturity and digital transformation, but each level also offers greater value. So why is digital transformation so important? A recent report on engineering and construction suggests that as much as 95% of all data created in the project lifecycle goes unused. While that stat is kind of frightening, we're beginning to see a shift in thinking and an increase in digital twin requirements in RFPs. Pretty sure you're seeing those too. That provides opportunity for a more collaborative approach on future projects. We have heard from owners that it can often take 9 to 12 months to go from project turnover to an operationally ready facility. Why is that? Because a repeatable BIM to FM process has never really materialized in the industry. At handover, owners and operators receive mountains of handover documentation that leaves them that insurmountable challenge in terms of creating an integrated solution for monitoring, managing, and tuning their asset. The result is that owners and operators are unable to realize the benefits of their smart buildings and instead end up with siloed data and systems, a lot of inaccurate information, a lot of silos, poor transparency, and not a lot of insight into their asset performance. What they need to receive at handover is that descriptive digital twin that indexes all of that documentation and puts the information they need at their fingertips, ready to be connected into a dynamic ecosystem. Another recent study by Accenture showed that the potential return on capital for an owner-operator could achieve through digital transformation. Not surprisingly, the biggest gains can be achieved by incentivizing project stakeholders to work in an integrated fashion and deliver digital, which can help realize more value through efficient use of resources and adoption of a more innovative process and methods. However, to achieve the full benefit, owners also need to invest in data sharing and data center talent. Autodesk TM was created to support your digital transformation and help move up that digital twin maturity scale, empowering owners and operators to realize their digital twin vision. With Autodesk Tandem, you can create and execute a repeatable process for curating a descriptive digital twin through a process we call digital handover, accelerating operational readiness. As we move forward, connecting Tandem to operational workflows and systems breaks down those data silos, giving the ability to create that single pane of glass for smarter operations. Analyzing the operational data collected by Tandem empowers greater insight to inform future decisions. I'll dig into Autodesk Tandem's digital handover workflow a little bit. How do we get from BIM to FN? And the point here is we want to harness the BIM process to make digital twins a highly repeatable, natural output of the project lifecycle. That all starts by really specifying the asset information requirements of the digital twin. The first step being to define the asset breakdown structure, which can either be based on a standard classification system, such as master format, uniformat, or omniclass, or you can build your own hierarchical classification system based on the owner's needs, possibly specified by an existing CMMS system. I'll show a quick demo later of how we incorporated the VBIS classification system into Tandem. Second is really leveraging and extending our data dictionary of parameters to define what data needs to be managed within your digital twin. These include simple values, document links, and outcomes. Standards like COBie, Building Smart, and the BIM map specification provide an excellent foundation for a data dictionary. And the final step is then creating a template that is reusable across facilities that specifies what parameter sets, what parameters apply to which asset types. This may often be prescribed by standards like COBie and BIMMAP. Note that each of these constructs are reusable across multiple facilities and they're fully versioned. So you can have data that is incorporated into a facility, continue to version those templates, incorporate additional data, and continue to grow your digital twin over time. The second step in the digital handover workflow is the idea that once the requirements are specified, you want to capture the required data from the design and engineering intent, from the as-built installation and commissioning data, and to verify the completeness and accuracy of the asset space and system data the owner needs to track. We connect to your common data environment to source model data via an integration with Autodesk Docs and BIM Collaborate. Today, we create twins from Revit and IFC data, but additional formats will be supported in the future. As model data is ingested into Tandem, a few things happen. First, we only bring in the changes from one version of a source model to the next. If only the fire rating parameter on 5 doors change, then only those 5 values will be brought into tandem. And we'll keep a change history of every change event to the twin over time. Second, we automatically classify the model data as best we can based on parameters we see in the source input. Third, we map parameter values from the source models into those asset information requirements that have been defined. And finally, we perform some spatial analysis, associating those assets to the rooms or spaces they're located within. That analysis is performed across the set of host models. So if the architectural model contains the rooms, the mechanical model contains the equipment, we correlate those two models to associate every piece of equipment to the room in which it sits. Once the model data is classified, it can be augmented with installation and commissioning data. That can be done directly in tandem. That data can be incorporated through Microsoft Excel, and we're working on integrations with Autodesk Build, with the Autodesk Build team on an integration with the assets module. So you can collect data in the field using BIM 360 Field or Autodesk Build, and basically bring that data directly back into tandem. What's happening inside tandem as you're performing these workflows is we're creating an asset information model. This is basically a digital twin ontology that includes all of the assets and equipment within the facility, the functional locations or the spaces within the facility, and most importantly, the systems and the relationships that connect the assets and spaces. This ontology will enable Tandem to answer questions like, where is this asset and how do I access it? Or if this component fails or I need to take it offline for maintenance, what spaces and people are affected by that event? Digital handover can help you achieve better outcomes really by two things: providing that data-centric platform for collaboration between the owner, the architect, and the contractor, and more importantly, at handover, providing easy access to the detailed facility information through that descriptive digital twin, which rapidly accelerates operational readiness of the facility. They can take that data, load it directly into their CMMS system, directly into their asset management systems, and start operating that facility from day one. More succinctly, we're building this workflow to really solve the BIM to FM gap. So far, we've talked about how we provide the descriptive digital twin context. Now let's look at how we'll connect that to operational solutions and data. We'll create those connections by linking the assets, spaces, and systems in Tandem to operational systems and data. We do not intend to replace existing operational systems or build our own IoT platform. Instead, we're working on connections to popular maintenance management, building management, IoT, and other systems. Through these connections to real-time and operational data, we'll deliver that single pane of glass for monitoring and operating a facility. Our goal is to create an informative twin by correlating all of that siloed data and leveraging it to create actionable insight. Last fall, you may have seen that Autodesk established a partnership with iOffice and SpaceIQ. We are going to take that partnership, and for customers who want a digital twin with operational workflows, we're working with our partner to offer an integrated maintenance and space management solutions. That data will be fairly seamless. If you've done the BIM to FM handover, it'll be available in those solutions automatically. As you're working in those solutions, that data will be visualized. All of the event history will be captured inside of Tandem. Moving further into the future, we'll leverage the data from the operational connections to enable predictive twins. By analyzing your desired outcomes against actual maintenance events and facility performance, we'll be able to report which assets and systems are performing as expected, better than expected, or worse than expected. This idea of being able to measure facility performance and understand the as designed versus the as built is critical for a digital twin. This information can help predict events to improve availability and obviously optimize individual facility and portfolio performance over time. Now that I've laid out the strategy, let's look at a brief demo in video form. I'll demo live afterward, time permitting. Take a look at our roadmap and how you can get started on your own digital twin journey. Here's a facility in Autodesk Tandem that was created from multiple source models. You can filter the data to isolate spaces, systems, and assets. First, we'll navigate into the mechanical room, select a pump. Selecting a pump provides access to all the metadata for that piece of equipment, including linked documentation, such as a detailed 3D model and assembly diagram shown. Navigating back out, we can isolate the hydronic system and start to examine sensor data associated with each component. The chart allows us to examine the time series data and look for anomalies. As we build out these capabilities, we'll add anomaly detection, alerting, and even ticket creation capabilities so that a facility tech can be dispatched to go look at a potential problem before it becomes a major event. The version of Tandem available now is really focused on that digital handover workflow for building a digital twin. That includes the ability to structure, gather, manage, and verify all of the facility data. We're constantly improving these twin building features and are working to add more support for automating system relationships, allowing for user refinement, creation and refinement of spaces, rooms, and obviously those integrations with operational systems. As you saw in the demo, we've begun working on informative twin capabilities for facility monitoring. This will include a simplified experience, targeted operations professionals with pre-configured views of data in context, and configurable dashboards. Integration with maintenance management, building management, and IoT systems is a key part of this phase of our roadmap. In the future, we'll expand further into predictive twin capabilities for optimizing a portfolio, and that will include the ability to roll up data across a portfolio of facilities and predictive analytics. A part of that roll-up capability is bound back into our idea of a facility template. We're using the same facility template for a set of data centers, healthcare centers, or other types of things will allow that data to roll up consistently and cohesively across the portfolio. Tandem builds on and extends the Forge platform, the Autodesk Forge platform. In parallel with the product features, we're also building out a set of APIs that will allow customers and partners to extend and integrate Autodesk Tandem. Again, the thought process here is a digital twin is not a single solution. It's always an ecosystem of solutions working together. And our desire is to enable that open ecosystem of solutions that can be plugged together to create a complete digital twin. Our goal with the platform is to enable the creation of really long-term a marketplace of digital twin integrations and data analytics. From our perspective, the value of Tandem in any digital twin is really in the data. It's useful to understand how we think about data and assets. When you import model data into Tandem, you're creating a context for your digital twin. A subset of that data is classified and tagged as assets. These are the assets, the spaces and systems in the asset information model that are structured for handover and make up that digital twin ontology. Again, this is typically an exercise of understanding what data is required. That typically happens in collaboration with the owner and then filling out that information through the design and construction process. As we build out those informative twin capabilities, a further subset of those tagged assets become connected to their physical counterpart via either sensors or via integrations to enterprise systems. When we think about a business model or a pricing for Tandem, it's really based on the number of assets being managed in the product. To get started, we do offer a free tier that supports importing an unlimited number of models and tagging up to 1,000 assets. Our subscriptions are based on 5,000 assets per annual subscription with an unlimited option. And for our Autodesk Enterprise business accounts, customers, we support a consumption model based on the number of assets tagged. All of these tiers support creation of an unlimited number of facilities with an unlimited number of users. The value is not in the user. You want as many people as possible to have access to that data. That's why the value is in the data. There's another short circuit that you might think, oh, a facility could contain an awful lot of assets. Bob, that's crazy. You can't do that. But if you think about different types of assets, you may have high value assets like a piece of mechanical equipment that you want to tag on an instance basis. And you may have low value assets like a light fixture where you have 1,000 of the same fixture in a building. You want to know their location, but for the rest, it's all type-based data. You want to know the model number, you want to know the product sheet, you want to know any other information at a type level. The type-based assets are charged as a single asset. So that helps bring the cost down significantly and make this quite reasonable. To get started with Tandem, you can literally visit our website in tandem.autodesk.com. You can sign up for a free version, access resources up there on the website. There's a bunch of getting started videos and other things, and subscribe to our webinars and product updates. Our LinkedIn page, Autodesk.tandem, is also a great resource for updates, invitations to webinars, other events, and of course, lots of digital twin information. With that, that is the end of my presentation. I am going to switch to a quick live demo, and I'll answer questions as I go into the demo. So I haven't heard a question, so I'm going to start in live demo for a moment. So this is an instance of Tandem in a Chrome browser. It's the same facility you saw in the video a few minutes ago. A couple of things. This is sourced from a collection of models. We've talked about that. You go to bring model data into Tandem. You can import that data from any set of files on your local file system or connecting into docs across any number of projects and accounts that you have access to with your Autodesk user credentials. If models have already brought in, you can get a notification anytime they change in docs, and you can quickly go and just update those models if the source files change. When you think about any of these objects, they're all selectable. You can see all of both the design element properties from Revit or the IFC file in Tandem. All of the design properties at both the element and the type level are fully available inside Tandem. Of course, what you really care about is these asset properties. I mentioned a few minutes ago that we do support different classification systems. One of the things I did in this model for this particular demo is you'll notice that it is classified using the VBiz classification system. If I expand this out, you'll notice here's the mechanical categories from VBiz. If I select this, you'll see it filters just to the VBiz classified items. I can also further take that and say, maybe I want to cluster this by family. It will then regroup the elements because maybe you want to look at things from a per asset perspective or a grouped asset perspective. That gives me the ability to look at all of these assets, select them. I can see their properties. I can do things with groups of properties, of parameters. If you don't want to work with data in a visual form, there is also a full inventory that shows all of the asset data for each object in the same that's filtered through this. You can create views of this information complete with the columns shown in the inventory, the exact view, the exact set of filters. You can save those as a view. You can recall those. Here is another view of the mechanical room, in this case isolated, and all of the elements within that room are color coded based on the model that they came from. So that shows our ability to look across the model sources, take this room geometry, and identify every asset from every model that sits within this room geometry. I'll stop there, see if there's questions before I proceed.
Hopefully you can hear me, Bob. It's Shannon here. Thanks for the presentation so far. I might just put it out to the audience if there's any questions so far for Bob from what we've seen. I think so far, so good. No questions at the moment. Did you have more just to show us through, Bob?
Yeah, I've got a few more things I can show for sure.
Yep.
I'm going to return back to the primary facility view. I'll go back into, get rid of the awful colors there. I'll go back into that. Actually, I'm going to go back into that mechanical room for a moment. So as we think about property data in tandem, one of the things that I talked about is the idea that you can specify what data you want to see on each individual asset. So as I select a particular component like that pump, I can see a set of asset data here that is sourced inside of Tandem, including links to things like mechanical documents or spec sheets, instruction manuals, et cetera. So I can link all that data directly to the asset. Warranty documentation, other types of things. This is completely configurable. So I mentioned early on the idea of identifying and specifying your asset information requirements. We do that inside of Tandem, inside this Manage tab. There is the notion of really a three-step process here. One, defining your classification. Tandem comes with a number of different classification systems out of the box, but you can also create your own. I mentioned we had VBiz here. This is actually the VBiz uploaded from an Excel spreadsheet. You can see all of that mechanical classification at its various levels. We can go to, like I said, if you have a existing CMMS system for a particular customer, you have a very simple set of categorizations. We can also create a very simple hierarchical system of classification for different types of things. Second step in this process, and I did mention BIM-map, but I did not have time to get the BIM-map parameter definitions in here, but you have the notion of a dictionary of parameters. We ship with a library of parameters that are fairly complete, coming from really the idea of building smart, COBie, those types of definitions. It's a fairly robust set of parameter values. You can also define your own. So in the case of bringing in the BIM-map parameter sets, you can bring those in, you can create the categories. Every parameter here has various things to it, a name, a category, whether it's applied to an element or a type level for the particular asset it's applied to, a description, a data type, which is basically follows all of our Forge Revit standards. It's all the same data type. If it's a numeric type, then you're going to get your typical types of units and precisions. And of course, you can restrict to a subset of values for pick lists and things like that. If it's a link, you can say any hyperlink will do, or I want to explicitly pick documents from within my Autodesk Docs environment. And then the last step in this is really creating that facility template. And that facility template is the idea that we want to bind a set of parameters to a particular asset type in a hierarchical way. So if we think about that mechanical specification, if I can find it, it is here. You can associate things. Actually, let me go create a template quickly to show how this works. I'll close this one. Creating a facility template. I'll create this. I'll create this based on that very simple sample categories. If I pick my doors, I can add a set of parameters at the door category. So maybe these parameters. So every door that I classify would pick up those three parameters. If I think about my exterior doors, maybe I want to pick up my life safety parameters, egress path, expected life, maybe fire rated, inspection required. So if I classify an item as an exterior door, it'll pick up all 6 of these parameters. If I classify an item as just a door, it'll only pick up the top 3 parameters. So this is how you build up those building blocks of data based on your asset hierarchy. Hopefully that makes sense. Going back to my facility, that gets applied in the pump example here by specifying a classification for that pump. This is the VBiz classification, and therefore it's picking up this set of asset identity data. If you want to map parameters from the source Revit file into Tandem, into these asset data, you can do that through the Assets tab. You can basically map any set of parameters from the Revit source file into the parameters in the asset information requirements. And this is going to spin for me and not do what I want. And that's what I get for using a staging version of Tandem rather than the production version. Apologies for that. This is not going to load. I'll stop again, see if there's any questions.
Thanks, Bob. It's Shannon here again. I guess just that demonstration there probably answered some of the questions I had, really around fit for purpose data sets and asset information requirements, and I guess you're showing us that flexibility of those particular data sets within Tandem. But it got me thinking a little bit more about another question, and I guess probably two points. One, around the timeline for predictive analytics. Is that something that you're working on and will be released soon, or is that something that's already available? And I guess maybe just a second question, if I could ask at the same time, is just around for project teams, if there's retrofits, the ability to update digital twins and models.
Both are great questions. I'm going to take them in reverse order. So as we think about retrofits, right? So we have customers that are building Tandem models today that are actually comprised of multiple projects, because the project is being initially built and there's actually a retrofit happening in parallel. And so Tandem can source data out of multiple Autodesk Construction Cloud accounts and projects. And this is very intentional because we want to allow this twin to have a lifetime that is much longer than the project lifecycle. So you can bring data in on initial facility creation. You may have a renovation of a floor or a system at a future date. That's another project. You're basically sourcing additional data. If you're just doing an upgrade on a component, that can be done through metadata changes without need to go back to Revit or design sources. So hopefully that answers that question, Shannon. And then on your first question, we are actively working on that time series data ingestion and display right now. What you saw in the demo video was very real. We demo that every day. We are about to introduce some alpha capabilities, and if people are interested, they can certainly reach out to me. It's going to be very early testing, but the intent is definitely to roll that capability out, probably in public beta in the fall of this year. That's our current planned timeline. And again, I had the safe harbor there, so you can't hold me to that, but that's our plan at the moment.
Sure, fantastic. I do have a question has been posted online. So it says, how scalable is the Tandem model? That is, can you do an 80-story building? Also, does it rely on Revit system connectivity?
So we have in Tandem today customers with facilities comprised of 40 plus models, 1 million plus elements, 1.5 million elements roughly. We do use some capabilities of the Forge Viewer. You are looking at a version of the Forge Viewer, but we load data very differently than Forge does, or Autodesk Construction Cloud for that matter. We load on demand from our database, and that makes Tandem much more scalable in terms of handling very large models. It is something we take very, very seriously. And was there a second question there, Shannon?
No, that was it. Just from the online question. I'll just run through it again just to make sure. So how scalable is the Tandem model, and can you do an 80-story building? I guess this is probably part of the second part of the question. Does it rely on Revit system connectivity?
So as we do system, that's what I was missing. Thanks, Shannon, for catching that. So as we're working on system connectivity, we do use relationships from Revit, but we're also using geometric math. So we look at data in a system, we attempt to couple things together that are near each other in terms of defining that system connectivity. And then we can do nearest neighbor, follow the neighbors kind of thing to show the entire network or the system, and basically allow the user to refine. We know models are not perfect. We know the systems inside models are not perfect. What we want to do is give the facility engineer a really good starting point and then allow for refinement. We're taking the same approach to rooms and spaces. We know rooms and spaces are never perfect, but if you get room data out of a model, maybe you want to extend 3 feet up so you get to the next floor plate. Basically provide that ability to start with the rooms defined in Revit and then refine, or basically create your own. That's work in progress right now as well, but it's near-term roadmap for us to have those capabilities.
Yeah, sure. Okay, I think we've got time probably for one more, and maybe one in the audience if there is one. But I've got another one online here, Bob, and so it says, can you access drawings from the models within Tandem?
We do not do drawing access today. It is entirely a 3D system. We do have the ability, interestingly, to, I don't think I have that turned on in this version. I do not. We do have the ability to generate 2D floor plans from whatever you have in filtered view. So if you have your mechanical equipment turned on, you'll get a floor plan with mechanical equipment. If you have, you want a floor plan with just spaces and rooms, you turn on spaces and rooms using the filters and we'll generate a 2D layout of that floor plan. That is really thinking more in terms of how we might use this model for space planning or for presenting it to a facility engineer, because they often work in 2D much more effectively than they do in 3D.
Yep, sure. Okay, we might just maybe just do one more reach out to the audience here and see if there are any other questions. I think we're all looking pretty good.
Excellent. Guys, can you put your hands together and please thank Bob? Thank you very much, Bob. Really appreciate it.
Thank you.